We've arrived at the property that we're going to survey. So one of the first things we want to do is take a photograph of the front elevation. So we shall do that now, and I find it best to do it when you first arrive because it can be easily forgotten when you're leaving. So if we do that, okay. Now, when we get here, one of the first things you need to do also is have a look at the base of the wall, the front wall there, to see if there are any air bricks, and that will help determine whether the floor inside is a concrete floor or a suspended timber floor, and we need to know the difference. So we can see here that it is, in fact, there are no air bricks, so it is a concrete floor, so we make a note of that. What we need to do now is, while we're outside and we can see where the meter box is, we want to open up the meter box, one of these keys, and you can get these keys in any of the hardware stores. They're very easily to come by. Looking for two things on the ESB meter. The first thing is a date. You can see it up here in the top right hand corner. That will help us establish how old the property is. And the second thing down here is this RM number. Now, if for some reason we can't get an ESB bill from the property owner, in order for us to get what's known as the MPRN number, we can then contact the ESB and give them that information, and they can then furnish us with that MPRN number. Okay, so we'll take our photograph of that. And we just need to get in, zoom in close so you get all the information that you need. And once that's done, then we can close up and carry on. So once we've closed up the meter box, make sure it's secure, we can go inside, and then we can start doing the assessment inside. Okay, so the way I do these is I come in and I start from upstairs. So what I would normally do is look in the attic first and then work my way down. Okay, so we'll just get the ladder, set it up and open up the attic hatch so we can have a look inside and see what insulation is up there. So first thing we'll do is we will measure the thickness of the insulation. So just get your tape, quite straightforward. So this measures just about 100 mil, which is the depth of the ceiling joist, which is not unusual. And then while we're here, we'll take a few photographs just to record that the insulation is actually here. So just a couple of shots in various directions, just to show that the insulation covers the entire attic area. Okay, so what we want to do, we finished with the attic, got the insulation information. What we want to do now is measure up, get the overall size of the house. So we'll do a measurement for across the width and down the length of it. And that will then allow us to start sketching up for each of the rooms. So we'll get the overall size and then we'll come into each room. And in each room, what we want to look at are what type of windows we have, what size the window opening is. We look at the radiators to see that they have any TRV valves on them. We look at the light fittings to see what sort of light fitting it is. And we'll check the walls to see whether it has any vents in it. And then we'll also measure the floor to ceiling height. So when we've done that, we'll do that for all the rooms and we'll sketch it as we go along. We can see that there's just about, we can get from there over to the far wall. And that way we get a measurement, a clear measurement across the width of the house. We can get the beam straight across to the wall. And we can take our measurement, and we have that at 4.862 meters. So I'll just make a note of that for the moment. And then I want to do the same in the other direction. So I just want to measure it along the length of the house. So which is 5.56 meters. Make a note of that. Right, so that allows us now to plot the footprint of the house, and I use squared paper, and each of those squares as a rough scale for me is 250 millimeters. So 4 of them is 1 meter. So I just count out the squares in each direction to get close enough to these dimensions, and that's accurate enough for these on-site sketches. Okay, so when we've taken the measurements for the overall footprint of the building, we got in this direction here it was 4.862 meters, and as I say, I just calculate that each of these squares is 250 millimeters, so 4 of them is a meter. So for that dimension there we measure across 16 and roughly about 19, so it's about 19 squares across this way, and that's good enough, accurate enough for what we're doing. In the opposite direction, the dimension was actually 7.378 meters, so again we just count down until we measure out to 7.83, and then we just draw on the footprint, and then we'll go into the front room there and sketch out the size of the room, and we look at the windows, the radiator, the vent and the light fitting, and we record all of those and then move on to the next one. We could start off with the front room here. So if we go in, so we just do a quick measurement in here just so that we can get it drawn up on our sketch just quickly. We don't need to record these measurements. So that's 2.6 meters. So again, we just measure across, count our squares. 1, 2, 3, 4. 1, 2, 3, 4. That's 2 meters. So that's roughly 2.6. And then in the other direction, we'll just measure from the wall of the window down to the back wall of the room. Now that we have that sorted out, what we want to do then identify where the window is. So I would normally just plot on the location of the window just schematically. You don't actually measure the location. What we need to do though is measure the size of the window. So we just do that. So we get a dimension of 1752 and the height, need to do that again. So we just write that down. So it's 1752 by 1181. So that's the opening for the window, and then we record what type of window it is, and we can see that it's double glazed. The spacer bar in between them is of the order of 20 mil. So what we need to note there is that it is, well, it's a PVC window. So we write down PVC. They're modern windows. They have draft stripping in them, so we'll say that they're draft stripped. It's double glazed, and as you said, the spacer bar, it's greater than 16 mil, so we write down 16 mil because in the software deep, anything greater than 16 is put in as if it was 16. And we can see from the radiator that there's no TRV valves on this radiator, so I just make a note of that on my own sketch. It's a rad and no TRV. Now we can also see on the wall we have a vent. Now if that vent can be closed, we ignore it. If it cannot be closed, we include it as a vent. And that's one that can be closed. So although the vent is there, I'll make a note that it is a vent, but it's a closable vent. And in deep, you do not include closable vents. Next thing we'll look at is the light fitting. And again, we'll just make a note of this on the sketch, and we can see that the light fitting is a CFL fitting, so we'll just make a note of that, CFL. And that measures 2.432 meters, so the ceiling height is how I just describe it. It's 2.432 meters. And I would tend to just use the same ceiling height throughout. In a house like this, it pretty much is. in other properties they may have different ceiling heights, and if they do, then you need to measure each one individually. So that's this room completed, and we just do the same then for the rest of the rooms upstairs. Okay, so another thing that's upstairs that we need to look at, usually on the landing or perhaps in the bathroom, is the hot press. And in here we will have our hot water cylinder. And what we need to do is take a photograph of it, see what insulation is around the cylinder, and then measure the size of the cylinder so we can calculate the storage capacity. So if we, in this case here, in fact the jacket is able to come away quite easily, so we can get a fairly good measurement on the size of the cylinder. And you can do it one of two ways. You can either measure the diameter, or if you prefer, you can take more of the jacket off and put your tape around it and try and measure the circumference. But for what we're doing, we're going to measure the diameter, which measures about 390 mil. And then we will measure the height. So from the floor up to the top of the cylinder, and that measures 920. So it's 390 by 920. So we record that, and we record the fact that it is a lagging jacket, and this lagging jacket, although it's old, it will still work, and it looks to be something of the order of maybe 30 mil in thickness, say 40 mil thickness. So we just need to record that. So we do that on the sketch, and when that's done, then we can move downstairs. Okay, so once we have completed upstairs and we finished off our sketch, this essentially is what you'd expect it to look like. We've recorded most of the information that we need from the survey on this sketch. On upstairs we had our hot water cylinder, and I've just recorded the dimensions for it here, the height and its diameter, and the lagging jacket that's around it, and that's located in the hot press. So as long as we just record the dimensions, then when we get back to the office we can calculate the actual capacity, and we'll be taking photographs of these things as well, and we do that before we leave.